So now let's learn three more terms: accumulation factor, discount factor, and present value. So if the annual effective compound interest rate is I, then 1 plus I is known as the accumulation factor. 1 over 1 plus I is known as the discount factor. And a very well-known and well-used symbol for the discount factor is nu. So nu is equal to 1 over 1 plus I. And the present value is the current value of an investment. For calculation purposes, it is just the principal. Okay, so let's look at example 7.1. What is the present value of an amount of 1 that you will receive n years from now if the annual effective interest rate is I? So 1 is the final amount that we will get, and we want to find its present value. So 1 is what we will get at the end of n years, and we want its present value. So in other words, we are asking how much should we invest now so that we get 1 at the end of n years. So in this compound interest formula, amount is supposed to be 1, and we have to find the principal. And from here, if we divide both sides by 1 plus I to the n, we get principal is equal to 1 over 1 plus I to the n, and 1 over 1 plus I is just nu, as we talked above. So principal would be nu power n. So if you invest nu power n now, you will get 1 at the end of n years. So another way to say this is that the present value of 1 that you will get at the end of n years is just nu power n. Example 7.2. At an annual effective interest rate I, the following are equal: the present value of 1,000 at the end of 6 years, the sum of present values of 600 at the end of year t and 5,600 at the end of year 2t, and 500 immediately. So 1, 2, and 3 are the same according to the given condition. Find the present value of 800 at the end of year t plus 4. Now, this problem is not an SOA sample problem, but it is very similar in spirit to the SOA problems, and so you may well see one like that on the exam. Okay, the present value of 1,000 at the end of 6 years. So we just did that example 7.1 to get a taste of how to get present values. So to get present value of something, we just divide it by 1 plus I power how many years we are dealing with. So 1,000. So the way you look at this is you're getting 1,000 at the end of 6 years, and we're talking about its present value. So the present value of that 1,000, which you will get at the end of 6 years, will be 1,000 divided by 1 plus I to the 6, or 1,000 nu to the 6, because nu is 1 over 1 plus I. And now this is what we get from condition 1, and since we are told that all 1, 2, and 3 are equal, so by condition 3, this one, whatever we got from 1 is equal to the 500. So this 1,000 nu to the 6 is equal to 500. And from here, when we divide by 1,000, we get nu to the 6 is 0.5. So nu is 0.5 power 1/6, which is 0.89. So now we use condition 2. We have used conditions 1 and 3 to get nu. Condition 2 says the sum of present values of 600 at the end of year t, so that'd be 600 divided by 1 plus I to the t, and 5600 at the end of year 2t, so the present value of that would be 5600 divided by 1 plus I to the 2t. So that's also equal to 1 and 3, and we'll just use 3 because that's a number. So the present value of those two, the sum of the present value of those two, 600 over 1 plus I to the t and 5600 over 1 plus I to the 2t, as we just mentioned. Present value of this first part is 600 divided by 1 plus I t, because that's the 600 you're getting at the end of year t. And similarly, this 5600 you're getting at the end of year 2t. So its present value is 5600 over 1 plus I to the 2t. And you have to take the sum of this one and this one, the present value of this one and the present value of this one. So we take that sum and we set it equal to 500. And our discount factor notation gives 600 nu to the t plus 5600 nu to the 2t equals 500. So now we rearrange terms. This looks like a quadratic equation, and in fact it is a quadratic equation in nu power t. So when you rearrange the terms and divide by 100, so dividing this term by 100 gives us 56 nu to the 2t. Dividing this by 100 gives us 6 nu to the t, and dividing this by 100 gives 5, and then you bring it on the left side, so it's negative 5. Now when you use quadratic formula here, it's quadratic in nu power t because you have nu power t here and nu power t whole squared here, so this is like an x. Nu power t is like an x, and nu power 2t is like x squared. So quadratic formula gives nu to the t equals negative 6 plus minus 6 squared minus 4 times AC, so 4 times 56 times negative 5. So the two values you get are negative 0.357 and 0.25. Now the discount factor or any of its powers can never be negative. So therefore nu to the t is equal to 0.25. And the question was, find the present value of 800 at the end of year t plus 4. So again, we have to familiarize ourselves how to read such statements. What this means is you're getting 800 after t plus 4 years, and you have to find the present value of that 800. So you divide the 800 by 1 plus I power t plus 4. So 800 over 1 plus I to the t plus 4, which in our discount factor notation is 800 nu to the t plus 4. And we will break it up into 800. So nu to the t plus 4 would be broken up into nu to the t times nu to the 4. And we already calculated nu to the t is 0.25. So 800 times 0.25. And nu we calculated earlier was 0.89. So nu to the t is 0.25 and nu is 0.89. So it would be 800 to 0.25 times 800 times 0.25 times 0.89 to the 4. So remember nu was calculated earlier as 0.89 over here. And so all this gives us 125.48. That's the present value of 800 that will be paid at the end of year t plus 4.